This program and its contents are designed for information and educational purposes only. This program does not render medical advice or professional services and is not intended to be a substitute for professional care. The information provided here should not be used for the purposes of diagnosing or treating a medical or psychiatric condition. If you have or suspect you may have a health problem, consult your healthcare provider. Positive Momentum would like to give a special thanks to Oracle Aviation at Millard Airport for use of their facilities and aircraft.
Greetings, my name is Benji Cunningham. I'm a certified flight instructor with an instrument rating, and today I wanted to talk with you about a couple of concepts that we as pilots learn and understand and know on how an aircraft does what it does. But before we do that, I wanted to point out one thing that's really important. Here's a couple pieces of paper that as pilots, and we teach our beginning pilots, a couple pieces of paper that you're going to look for to know that the airplane is what it is and it's going to do what it's supposed to do under certain specific standards. One of which is what we call the airworthiness certificate. This certificate here basically says that this type of aircraft that we see right here is airworthy. So it's actually able to do what you're supposed to do. We also have the air registration as well. So these two pieces of paperwork we take a look at as we're starting our pre-flight checklist. It's the first thing that we go through, and it's kind of an acronym that we use. But airworthiness, the registration, does it have an operating handbook? And we'll talk about that further in the checklist portion of it. But the other point I wanted to point out to you is, obviously, this is the aircraft wing. This is where the magic happens. But the interesting point as far as where the magic happens is the aircraft flying, it's all about aircraft airflow, or airflow over the wing. As we've spoken about before, and I talk about this to multiple people, and kids that want to learn why does the aircraft fly, is if you had two pieces of air molecules and they were hitting the beginning of the wing at the same time, these aircraft molecules, it's going to be a race to get these two air molecules from the front end to the back end, okay? And there are certain concepts, mathematical concepts that have been discovered way back in the 1800s as far as why, or let's just say early 1900s, as to why the aircraft acts the way that it acts. What happens is that the airflow that happens above the wing and the airflow that happens below the wing, they happen at different speeds. So as it's traveling faster over the top of the wing than it is over the bottom of the wing, there's actually less pressure on top of the wing. Where there is less pressure, just due to the faster flowing airflow than it is underwards, then the higher relative pressure is going to go to the lower relative pressure, hence creates lift. So that's what's happening all throughout this wing. Okay, if you come over here, I wanted to share with you, you can see that these wings and the wing design isn't necessarily equal. You'll see that there's more curvature on the top of the wing than there is on the bottom. So when the airflow hits on the bottom, it goes right through. So this airflow has to travel faster. And it's the smooth airflow on top of the wing that causes this whole magic to happen. So it's good, smooth, magical airflow. The other point that I wanted to make to you, so that's just the magic of the airfoil, okay? The other point that I'll make to you too, if you'll come right over here real fast, is the same concept of airflow is the same exact concept of airflow. This is an airfoil, the same exact way. So when this propeller is turning, it's literally creating lift. So it's lifting, which is the thrust. So this is actually curved. This is an airfoil. Exactly just like this is an airflow. Exactly like it is in the propeller. And also it's the same concept on the back of the wing too, where there's actual airflow that happens on the back of the wing as well. The other point that I wanted to point out to you was just some parts of the wing. What makes up the wing? So when you're in a commercial airliner, you're seeing these moving parts that are happening on the wing. This is what we call the aileron. The aileron helps the aircraft or the airplane turn on one of the axes. There's actually 3 axes, and we'll talk about that more in class. But what makes that happen is the aileron, moving up and down. What you'll find too when you're flying is what I'm fascinated by as a pilot is the very how little it moves to make that whole aircraft turn on its axis. Is that this doesn't turn a lot, but it does have a lot of play. Okay, so from a concept on why it does what it does and has more increase in lift and decrease in lift, and if I can point one other thing out to you as well, I wanted to point out to you how the aircraft control actually in the cockpit, when I'm moving this in this smaller aircraft, you can actually see the control wheels moving simultaneously in the same manner. What other point did I wanted to make to you? The other point that I wanted to make is the smoothness of the surface, which is really important as well. The smoothness of the surface enables the airflow to stay attached to the airflow. If you'll see in golf balls, sometimes in the golf balls you'll see the dimples, and the dimples in the golf ball enable the airflow to stay attached to the sphere, and that's exactly what happens to the same concept in the wing. So at this point in time, I guess that's everything that I would have to say as far as why an aircraft flies the way that what the aircraft does what it's supposed to do, is because it's all about the shape of the airfoil. And there's also a couple of other things as far as the curvature of the airfoil in the airplane and the differences in the curvature on top and the curvature on the bottom. If you see over here, you can actually take a look at the profile, and you can actually see that it's actually canted all the way up, so you can see it's helping the airfoil, right? Helping the airfoil in the airflow. When you bring the aileron down, you can see that the wing will actually increase in curvature. Okay, you can see that the angle, and it's all about the angle of attack. So those are a few things that we'll talk about further in the studio and in the classroom, where I have some other images to help you understand that. So, all right, this is Benji Cunningham signing off.